Okay, good evening, everyone. Can someone let me know if I'm audible and if my screen is visible?
Yes, sir. It is visible, sir.
Okay, thank you so much. So let us get started with this week's content of the Introduction to Database Systems tutorial. In the last week, we did not complete the week 3 content, so we would quickly go through that content and then start with week four's content. And let's hope that we are able to catch up. So, if there are no questions from the previous tutorial, we can get started with the upcoming questions. But just in case there are a few questions, do let me know. Okay, so I think this is the question that we will begin with. Sorry, what's happening? Yeah, so here is the question. You're given two relations, A with the attributes x, y, z, and B with the attributes d, e, f. You want to find the tuples in A when joined with B under the condition that the value of x in A should be greater than or equal to the value of d in B, or the value of z in A should be less than equal to the value of f in B. Okay, so is there anyone who has an answer to this question? Okay, so let us see how do we solve this question. So over here in the question, we are supposed to follow two steps. The first step is to take a join of the two table and then look at certain conditions that are to be met by each resultant tuple. Okay, so to perform a join, what do? You take the first row of, you take one row of the first table and join it with every row of the other table. So I will take the first row of the blue table, which is 1, 2, 3, and I will try to join it with the first row of the green table, that is 1, 2, 4. and I will check whether joining these two rows satisfies or does not satisfy the condition that is given to us. So if I join the first row in blue with the first row in green, does it satisfy a dot x is greater than or equal to b dot d? So 1 is greater than equal to 1. So therefore this condition is satisfied. So you get 1, 2, 3, 1, 2, 4 as one row in the resultant. Then let us try to join the first row of the blue table with the second row of the green table. So does a dot x greater than equal to b dot d hold? No, it does not hold. But we also have another condition that a dot z should be less than or equal to b dot f. Does that hold? It does, because 3 is less than or equal to 8. So therefore you again get 1, 2, 3, 2, 4, 8. Next, let us look at the second row of the blue table, which is 4, 5, 6, and join it with the two rows of the green table. So because a dot x is greater than equal to b dot d for both rows, because 4 is greater than equal to 1 and 4 is greater than equal to 2, so you could again join both the rows with 4, 5, 6, and therefore you get 4, 5, 6, 1, 2, 4 and 4, 5, 6, 2, 4, 8. So here is the answer. So you get 1, 2, 3, 1, 2, 4, 1, 2, 3, 2, 4, 8, 4, 5, 6, 1, 2, 4, 4, 5, 6, 2, 4, 8. So is this understood? How did we get the answer? Are there any doubts with this question? Okay, so if there are no doubt, sorry, yeah, is there a doubt?
No, sir. It's clear. It's
Okay,
clear. Go ahead.
okay, yeah, thank you. Let us move to the next question. So the question is, can the following operation be performed? If yes, what is the result of the operation? And if no, why is the operation not possible? So the operation that we are talking about is the difference operation between two tables A and B. And you need to identify what A minus B would be, where A is the blue table and B is the green table. So is it possible to subtract the two tables or the two relations?
No, sir, because the number of attributes are different.
Yes. Uh, so that is indeed the correct answer. So these two tables cannot be subtracted because these tables are not union compatible, and which is essentially that there are no corresponding attributes in the across the two tables. So for union compatibility or for subtraction to be a legal operation, you should have the same or mappable features. Over here in this case, one could argue that x can map to d and y could map to e, but there's no attribute to which z can map. So therefore, this the set difference operation cannot be used over here. So is the idea clear or not? Is there anyone who wants me to repeat this? Okay, so if this is clear, let us move to the next question. So you're given two relations. The first is A, which has three attributes x, y, z, and corresponds to the blue table. And the second relation is B, which has two attributes x, y, and is denoted by the green table. Now you need to identify what is the result of the operation A divided by B. So can someone tell me what would the structure of A divided by B look like, or how many attributes and which attribute would you have in the resultant A divided by B? What attributes would be there in A divided by B? Okay, there's one answer which is X and Y. Any other answer? So it is actually the case that when you divide two tables, the resultant would be the attribute which is present in the first table but not in the second table, all such attributes. So what is the attribute which is present? What is a set of attributes which is present in the first table but not in the second table? It is only Z. So therefore the output of this division operation would be Z values, or a relation with only attribute Z. So is everyone comfortable over here with the division operation, or do you want me to solve this question and explain it to you? Okay, so let me explain how to solve the division operation because it is slightly trickier than other operations. So let us consider this example wherein you have xyz in the first table and xz in the second table. So the output of this would be the set of values of the attribute which is present in first table and not in the second table. So all such attributes would be a part of the output. In this case, there is only one such attribute which is z. So the output would be a z value, set of z values. Okay. Now, what does the output satisfy? So the output would be those z values that are present in A, that are present in the blue table, and combine with all the rows in the green table, and this combination is found in the blue table. So this is slightly complicated, so let me give you an example to explain this. So let us look at the value z equal to 8 in the blue table. If I take z equal to 8 and combine it with the two rows in the green table, what do I get? I get 258 and 378, right? What did I do? I took z equal to 8 and combined it with both the rows or all the rows in the green table. So when I took z equal to 8 and combined it with the two rows in the green table, I got 258 and 378. Now the question is 258 and 378 present in the blue table? Yes, we have 258 and 378 in the blue table. So therefore the output would have z equal to 8. Now let us look at z equal to 6. Okay, z equal to 6 is also present in the blue table. If I combine z equal to 6 with the two rows in the green table, what do I get? I get 256 and 376. Do I have 256 and 376 in the blue table? No, I do not. So therefore 6 will not be a part of the output. You also would have to check other values of z such as 4, 6, 5. Okay. So is the idea clear? How do we, what happens when we are dividing one table with another? Is there anyone who wants me to repeat this again? If there's anyone who wants me to repeat this in, let's say, Hindi, that is also doable as long as it helps you to understand the concept clearly. Okay, so if this is understood, can you now try to find the answer for this question? So we saw that z equal to 8 would be one answer. Are there other answers also? Yeah, so 4 is again one possible answer. So I can see that there's one answer which states 254 and 374. So you're correct in the line of thinking, but the answer would not be 254374 because we saw that the answer or the resultant table would be a table of attributes that are present in blue but not in green. So that is only one attribute, that is Z. Okay, so I hope that clarifies that it is not 254 and 374 but only 4 that should be present in the output. So this is the answer. This is how the answer would look like. Okay, 6 would not be a part of the answer because if you take z equal to 6 and combine it with the green table, you get 256 and 376. We see that 256 is in the blue table, but 376 is not there in the blue table. So therefore 6 will not be a part of the output. Okay, so I hope the division operation is clear to everyone. We will be revisiting the division operation once again with a slightly more difficult problem, but I think as long as your understanding is in place, you should be able to answer that question. Okay, so moving to the next question. If the division operation is clear, if not, please feel free to let me know. So, uh, I suppose things are fine with the division operation. So let us move to the next question. You're given two relations x and y. X has three attributes, namely a, b, c, and y also has three attributes, c, d, e. We notice that x and y have a common attribute, which is c. The question is, what is the result of the operation wherein you join x with y such that x dot c is equal to y dot c? The first option is x union y. The second is x intersection y. The third option is x minus y. And the fourth option is x natural join y. Okay, we have one answer which is union. Is there anyone else who thinks that union should be the correct answer, or is there someone who thinks that some other answer could be correct? Okay, so the correct answer over here is actually the natural join operation and not the union operation. So the first thing that we need to take care of when we are considering union, intersection, or subtraction is whether these attributes are compatible with each other or not. So over here, for example, a b c could be integers for x, whereas for y, c could be an integer because it is a common attribute with x, but d and e could be, let's say, date of birth and name. Okay, so if you have such attributes, then these tables are not union compatible because the attributes do not have mapping with each other. Do you get the point? So therefore, union, intersection, subtraction would not even be defined in this case because of lack of union compatibility. On the other hand, if you look at the definition of natural join is essentially joining two tables while ensuring that the join condition is that their common attributes match, which is exactly what is happening in the expression that is given above. So therefore the answer is x natural join y. Do you get the point? Okay. So if this is clear, let us move to the next question. So the next question is that you have to explain how the following three operations can be expressed in terms of operators from the set select, project, join, unconditional join, union, and subtraction. So you want to simulate intersection, natural join, and division. I have already given you a hint as to how do we simulate the natural join between two tables. Can you try for intersection and division? So let us try to first do the intersection and natural join. Division is slightly more involved. So please try to do the first two. Okay, so any answers for the natural join part? How do we simulate natural join? Okay, so natural join is simulated by first doing an unconditional join and then using a select condition on the common attribute. This is exactly what we saw in the previous question, right? That you first do the join, which is denoted by the cross operator, and then you have a select condition wherein you have x dot c equal to y dot c. So this is essentially a condition to imply that you want the common attribute to be the same. What about the intersection operator? How can you denote the intersection operator or simulate the intersection operator using other operators, let's say union and subtraction? Anyone who has an idea of how to do that? Okay, so let us see how do we do that. So the intersection operator can be simulated by using only two operators, which is the union and subtraction operator. So over here, I'm using the Venn diagram notation that we saw in the week zeros tutorial, where you have two sets A and B. In the context of DBMS, A and B can also represent relation because relations are also sets, wherein in each relation it is a set over the rows in the relation, right? So you have A and B, which are denoted by these circles, and there's a common region between A and B which denotes A intersection B. The left region denotes A minus B, which is the region which is exclusively present in A and absent in B, whereas the rightmost region is denoted by B minus A, which denotes the region which is exclusive to B and not in A. And we know that a union of the two sets A union B would be the region which is there either in A or in B or both. So is it clear from the diagram that A intersection B would be A union B minus A minus B minus B minus A? Are there any doubts in why this is the case? Okay, so if this is clear, then we have solved two of the three parts in the table, wherein we have simulated the intersection operator using union and subtraction, and we have simulated the natural join using cross and select. Now the final question is, how do we simulate the division operator, which is a slightly tricky situation to or a slightly tricky question. So I'll probably give you 5 minutes to think through this. If you're able to solve this, then I can assure you that you have understood the question very well. Okay, and question or the division operation very well, and then you would never have a difficulty in the understanding of how the division operator works and what does it do. Uh, okay, so you're saying that it is subtract operator, but over here you cannot really subtract the two tables, right? Because for subtraction you need union compatibility, which is what we saw earlier, right? Two tables with different number of attributes cannot be subtracted. So to channelize your thought process, I would suggest you to take the approach that we took to solve the previous division operation question. So what did we do? We identified all the candidate Z values that should be inspected. Then we combined those Z values with the green table. Then we checked which values are present in the blue table or not after joining. And only particular values of Z were selected in the output. So if you follow this, I think you can make it to the final form. Okay, I'll probably give you a few more minutes to think through it. I would encourage you to not give up easily, but rather try to critically analyze the question and see how it can be approached. Remember how we tried doing things? First, identify candidate Z values. Try to try to combine them with the green table, and then see which values are present, which are not. Is there anyone who could go slightly towards the goal, or you tried to make some effort? Okay, so let us try to solve this question. So when we were solving the previous question, what did we do? We first looked at all possible values of Z, right? So what are all the possible values of Z? How can you obtain that? You can obtain that by projecting the values of Z from the blue table. What do you get? You get Z equal to 3, 4, 5. So these are like the candidate Z values that you have, right? So I hope this much is clear for the time being. We first projected the value of Z's. Out of these projected values of Z, some would be in the final answer, some would not be in the final answer. And now the next step is to identify which should be retained, which should not be retained. Okay, so now you have the candidate values of Z. What did we do next? We joined these values of Z with the rows in the green table. So we performed a join operation, and the join operation would give us a table of XYZ values. So if you join these Z values with the green table, you get 1, 2, 3, 2, 4, 3, 1, 2, 4, 2, 4, 4, 1, 2, 5, 2, 4, 5. Right? So is this much clear? Are there any
Yes,
doubts?
sir.
Okay. So now the question is, we need to identify all the values of Z that combine with uh, every row in the green table and is indeed present in the blue table, right? So this is the next step that we need to ensure. So how do we do that? We subtract the two tables. So I do red minus blue. So when I do red minus blue, what do I get? I get all the tuples or all the rows in the red table which are not present in the blue table. So what are such rows? It is only 244, which is present in the red table but not in the blue table. Now what do I do by achieving this? Why did I even subtract? So when I subtract when I do the operation red minus blue, what am I getting rid of? I'm getting rid of all the tuples that are in red and in blue. So these are precisely the Z values which combine with the green table and are present in the blue table. And the output of the subtraction, which is 244, captures that Z value which is there in the red table but not in the blue table. So Z equal to 4 is there in the red table. I mean, Z equal to 4 is a problematic case. So let me go back to the previous slide and show you why Z equal to 4 is a problematic case. So if you look at Z equal to 3, like we did before, if I take Z equal to 3 from the blue table, maybe I'll go, sorry, give me a minute. Yeah, so when you were solving this, what did you do? You took Z equal to 3 and combined it with 124, 244. And we saw that 123 and 243 are present in the blue table. So Z equal to 3 should be a part of the output. Then we looked at the next value of Z, which is 4. I combined it with 124 and 244. I combined it with the green table and I got 124 and 244. Now 124 is present in the blue table, but 244 is not present in the blue table. So 244 is a problematic case, because of which 4 should not be Z equal to 4 should not be in the output. Now the next value of Z is 5 and you combine it with the green table. So you get 125 and 245. And you notice that 125 and 245 are both present in the blue table. So therefore Z equal to 5 will also be in the output. So the output would be 3 and 5. Why is 4 not present in the output? Because 1 to 4 is 1 to 4 is present in the blue table, but 244 is not present in the blue table. So 244 is something we need to point out. So that is why we produce the subtraction operation. So the pink table was essentially a table of expectations, which said that if 3 were to be in the output, then 1, 2, 3 and 2, 4, 3 should be in the blue table. If 4 is to be in the output, then 1 to 4 and 2, 4, 4 is to be in the blue table. And if 5 is supposed to be in the output, 1 to 5 and 2, 4, 5 is to be in the blue table. And where is the expectation failing? The expectation is failing at 244, because 244 is present in the pink table but not in the blue table. Now, so we have identified that z equal to 4 is problematic, but z equal to 3 and 5 are not problematic because they are present in the blue table. So we now just need to get rid of z equal to 4, which is the problematic z value. So we again project the value of z and subtract, so we get z equal to 4 and subtract it from the yellow table, and we get the answer as 3 5, and which is indeed the answer for the division operation. So is this clear, or do you want me to repeat this again? I know it is complicated, so it is perfectly fine if you want me to repeat it again. Okay, so let us go back. Okay, let us try to see how do we perform the division operation again. So what is the result of the division operation? It is a table of attributes which are present in the blue table but not in the green table, right? So what are all such attributes? In this case, it is only z. So the output of the division operation would be a table of z values. Is this much clear? So please interrupt me at every stage so that we are on the same line, and then uh, so that your understanding is as best as possible. Okay, so the output is a value of z, a table of z values. Okay, now now we need to look at different possible candidate values of z. So what are all the possible values of z that you have in the blue table? It is 3, 4 and 5. These are the distinct values of z that you have in the blue table. And so the output would be a subset of these values. So either all of 3, 4, 5 would be present, or some would be present, some would be absent. So uh, so we would be considering these three values of z. Those are 3, 4 and 5. Now to decide whether these values will be present in the output, what do? We take the first value z equal to 3, combine it with the green table. So when you combine z equal to 3 with the green table, what do you get? I get 1, 2, 3 and 2, 4, 3. Now I check if 1, 2, 3 and 2, 4, 3 are present in the blue table. So I see 1, 2, 3 and 2, 4, 3 in the blue table. So therefore, the output would have z equal to 3. Is this understood why output would have z equal to 3? So Tejaswini and okay, so we have Krishna, Tejaswini and Dipali. Is this clear to the three of you that z equal to 3 should be a part of the output, or would you want me to repeat again? Okay, so if this is clear, let us look at z equal to 4. Now let us look at the second candidate, which is z equal to 4. So I take z equal to 4, join it with the two rows of the green table, and what do I get? I get 1, 2, 4 and 2, 4, 4. Now I check if 1, 2, 4 and 2, 4, 4 are present in the blue table. I see that 1, 2, 4 is present in the blue table, but what is not present in the table is 2, 4, 4. So therefore 2, 4, 4 is a problematic case, because of which 4 will not be a part, z equal to 4 will not be a part of the output. Is this clear? Okay. Now what is the last candidate value of z? It is z equal to 5. I take z equal to 5, combine it with the two rows in the green table, and what you get is 125 and 245. I see that 125 and 245 are both present in the blue table. So therefore z equal to 5 will also be a part of the output. So your output would be a table of z with values 3 and 5. So is the output of the division operation and the procedure clear to you? Any doubts in this? Okay. So now let us look at how do we simulate this. So how do we put this thought process in practice? So firstly, what did we do? We identified candidate values of z. So how do we get candidate values of z? We just project all the distinct values of z by the project operator, which is denoted by pi subscript z. So after projection, you have this yellow table, which is a table of candidate z values. A few of these values would be retained and the other values would be discarded. So we have first constructed a set of candidate z values. I suppose that is clear to everyone. Any doubts in this? Okay. Now that we have the set of candidate z values, what did we do next? We took every z value and combined it with the green table in order to create expectation. So when you create the expectation, what are you doing? You're essentially doing a cross product. So when you're taking the cross of the green table and the yellow table, what do you end up getting? You end up getting this pink table. So you get 1 2 3 2 4 3, 1 2 4 2 4 4, 1 2 5 2 4 5. So is this clear that we have constructed a table of expectations? Any doubts in this until this point? So why do I call this a table of expectations? This is a table of expectations because if 3 is to be, if z equal to 3 has to be in the output, you need to have 1 2 3 and 2 4 3. If 4 is supposed to be in the output, you need to have 1 2 4 2 4 4 in the blue table. If 5 has to be a part of the output, you want 1 2 5 and 2 4 5 in the output, in the blue table, sorry. So this is a table of expectations. Is this clear? Is there anyone who wants me to repeat this? I would really appreciate if you just. Okay, so Tejaswini, I suppose when you said no, it's that things are clear. Mm, okay, so now we need to identify what are the rows in this pink table which defy the condition, which do not satisfy the condition or violate the condition. So I need to identify all the rows in the pink table that are absent in the blue table. So what would this do? This would highlight problematic cases for me. So I see that 1 2 3 2 4 3 is present in the pink table and the blue table. So the subtraction, yeah, these slides are available after, these slides would be available. I would upload it in a Google Drive. Okay. Yeah, so coming back, when I perform the subtraction, what am I doing? I'm essentially seeing what are the particular rows which satisfy the expectation and which do not satisfy the expectation. So because 1, 2, 3 and 2, 4, 3 are present in the pink table as well as the blue table, these rows are excluded. Similarly, 1, 2, 5 and 2, 4, 5 are also present in the blue table. So these rows would also be not part of the output. But what would be a part of the output? It would be uh, all those rows which are problematic. So 244 is a problematic row. What does it mean when I say that 244 is a problematic row? It means that z equal to 4 could have been in the output, but it is not, it should not be there in the output because 244 is not present in the blue table, right? If 244 was to be present in the blue table, 4 would also have been in the output. So is this clear why the subtraction is why the subtraction highlights the problematic cases? Okay, now that the subtraction has highlighted problematic cases, the only thing that we need to do is to get rid of these problematic z values. So the problematic z value in this case would be obtained by projecting the z value from this table, which gives you z equal to 4, and finally excluding that z value from the candidate z values, which is the yellow table. And what you get as the output is the green table, which is z equal to 3 and 5. So is it clear now? Any doubts in this? Okay. Okay, thank you for confirming. So this was the last question from the previous week's tutorial. So if this week, if these set of questions are clear, I can go to the next set, but I'll give you like a minute to raise any doubts if you have. And if there are no doubts, we can proceed to the next week's tutorial or the current week's tutorial. Okay, so I don't see any doubts now. Okay, so this is week 4, uh, set of questions for week 4. Now, so here is the first question. So given the basic ER and relational data models, which of the following is incorrect? The first option is, in a row of relational table, an attribute can have more than one value. An attribute of an entity can be composite. In the relational data model, the domain of any attribute cannot be a set of pairs of integers. And the last is, a superkey of a relation is an attribute or a group of attributes that can uniquely identify a tuple in any of its instances. So, which of the following are incorrect? Okay, there's one which says 3. Anyone else? Okay, so I see that there are, okay, there's the first option. Okay, so for 1 and 3 seem to be the choices which are suggested in the chat section. So let us try to investigate each option carefully. In the first option, we have in a row of a relational table, an attribute can have more than one value. So we restrict ourselves to one row and in that one attribute. So we are looking at one cell at a time. Now in one cell, can you have more than one attributes, more than one values? So the answer is no, you cannot have more than one values because we have an atomicity constraint wherein each row will have exactly one value. Now, the source of confusion over here is when you have something like a composite attribute or a multi-valued attribute. So when you have a composite attribute, let's say someone's name, a composite attribute such as someone's name, which is first name, middle name, last name, typically, but not necessarily. So in that case, you could argue that because these are like three values, first name, middle name, last name, how do you regard it as one value? So although it has components to it, it would still be regarded as a single value and not different values because it corresponds to exactly one entity, and you would assume that this name would not be broken down into further chunks by any process. Okay, so although a composite attribute, let's say my name Advait Pramod Parsodkar, would have three components, this entire string of three substrings would be considered as one component and not three components. Okay, so these are not more than one value, but exactly one value. Then someone might also argue that you can have multi-valued attributes wherein you have, let's say, different phone numbers for a person. So again, these different phone numbers cannot be broken down into smaller chunks. This has to be treated as one set, and therefore it is still considered as one value and not multi-valued. Okay, then let us look at the second option. An attribute of an entity can be composite. So we have already seen that there are composite attributes. So this is definitely correct. The third option is in a relational data model, the domain of any attribute cannot be a set of pairs of integers. So this can very well be a set of pair of integers. For example, a composite attribute could have, let's say, so an attribute x can be comprised of x1 and x2, where x1 is an integer and x2 is an integer. So this would result in x being a set of pair of integers. So this is also not a problem. And the last one is the definition of super key, so that is also correct. So is this clear why one is incorrect and others are correct? Any doubts in this? Okay, so here is the answer. So moving to question 2, you're given two statements. Statement 1 states that existence of multiple foreign keys in the same relation is possible. And the second statement is each record of referencing relation can relate to at most one record of the referenced relation. You need to identify which of these, whether S1 is true and whether S2 is true. Okay. Anyone else? Okay, so 1 seems to be a popular option, and that is indeed the correct answer. So you can have multiple foreign keys in the same relation. Can somebody give me an example of this? So you could have a relation wherein you have, yeah, employee ID and department ID. So you could have a relation corresponding to the employees in CS, employees in an institute. So you would have an employee ID and a department ID. Employee ID would be a foreign key to an employee table, whereas department ID would be a foreign key to a department table. So that is definitely possible. And each record of a referencing relation can relate to at most one record of the referenced relation. So this is also true because foreign keys are again keys. So they have to refer to exactly one record in the referenced relation. So therefore S2 is also true. Is this clear, or is there anyone who wants me to repeat this again? Okay. Okay, repeat S2. So what does S2 say? That if I have a foreign key in a table, for example, an employee ID or a department ID. So let's say there's Professor Deepak, and there's a foreign key corresponding to department which is 2. Now this 2 is a foreign key to another table. So this 2 should only correspond to, let's say, uh, one row. So 2 would correspond to, let's say, CSA department. So it should only correspond to one row. It cannot be the case that 2 corresponds to CSA department and EE department or mechanical department. Right? So this 2 should refer to at most one record of the reference relation. Is that understood? Okay. So moving to the next question. You're given two tables. The first is called employee information, which has three attributes: employee ID, employee name, and city ID. And the second table is called city information, which has two attributes: city ID and city name. Now, the city ID in the first table is a foreign key that refers to city ID in the second table. Okay. Now the question is, which integrity constraint is violated in these tables? Which question do you want me to repeat again? Is it this question or previous one? Oh, I've not even given you the answer, so yeah. Okay, so there's one answer which states that there's no violation. Uh, okay, so there's indeed one violation over here. That 12 refers So the first row has city ID equal to 12, which suggests that Ashish is from Chennai. The second row has city ID equal to 1, which suggests that Manoharan is from Bangalore. But then for 13, you don't have any entry in the second table. So you do not know where Venkat belongs to. So this is what is referred to as referential integrity constraint, wherein not all foreign keys map all to a row in the second table, and you would want this referential integrity constraint to hold so that you do not have these dangling pointers or dangling foreign keys. So is this clear? I think it's more of a theoretical question, so there's not much to explain. But okay, so I hope you understand. Yeah. Okay, so moving to the next question then. You're given two relations A and B. A has two attributes xy and B has two attributes yz. The question is, you need to identify the left outer natural join of A and B. So, what is the left outer natural join of these two tables? Okay, so when we are looking at the left outer natural join, what do? We first do the normal join. So for example, you have 1 2. So we are joining these two tables and the common attribute is y, and we saw that natural join is essentially joining under the condition that the common attribute has the same value. So a normal natural join, what would it return you? It would look at 1 2 in the first table and join it with 2 4 in the second table, because the corresponding y values are the same. So you get 1 2 4 as one output. With 1 6, do you have anything in the second table? No, because there's no y equal to 6 in the second table. Then for 3 4, the third row in the first table, you have 4 1. So you get 3 4 1 as the result. And with 5 2, you have 2 4. So you get 5 2 4. So this is what a normal join would give you. A normal natural join would give you. When you have left outer join, what happens is it retains everything that is present in the left table. So previously we did not retain everything which is present in the left table. For example, we dropped 1 6 because 1 6 did not combine with anything in the second table. But now what would you do? You would retain 1 6 by saying that 1 6 null. That indicates that there was no corresponding row in the second table. So this is so the output would be the third option: 1 2 4 5 2 4 3 4 1 and 1 6 null. Is this understood? Is there anyone who wants me to repeat this? Okay. So moving to the next question. You have three tables: person, works, company. Person has four attributes: Aadhaar ID, name, age, education. Work has three attributes: Aadhaar ID, company name, and designation. And company has two attributes: company name and headquarters location. You are given this relational algebra query where you first construct two sets: projected Aadhaar ID, name, and age of person, and projected Aadhaar ID, name, and age of person joined with works. Now the question is, which of the following statement describes the output of the query? The first is it outputs Aadhaar, name, age of all people. Second option is the details of all employed people. The third option is the details of all unemployed people. And the last is none of the above. Okay, we have C as a popular option. Anyone who does not agree that C is the correct answer? Okay, so it is indeed C that is the correct answer. So an explanation for this is that the first term gives you Aadhaar ID, name, and age of all people. And the second term gives you Aadhaar ID, name, and age of all employed people. So the difference would give you Aadhaar ID, name, and age of all unemployed people. I hope this is clear. Are there any doubts in this? Okay. So we have again the same set of relations: person, works, and company with the same set of attributes. Now you have a relational algebra query wherein you first select all the rows in works that have company name XYZ, join it with person, and then project their Aadhaar ID, name, and age. Now the question is, you need to identify what is a correct tuple relation calculus query for this. What is an equivalent in TRC for this relational algebra expression? Okay. Just a note over here, the star operation is essentially used to denote a natural join between the two tables. It's not just a join, but a natural join. Okay. Okay, so is there anyone who has a different answer? Yeah, so the V is for or, and the caret symbol, which is an arrow pointing up, looks like an arrow pointing up. That is an and symbol. Okay. So this is for or and this is for and. Okay, so the correct answer for this is indeed option D. So when you're doing, so first of all, over here, what is the output that we want? If I wanted to write a TRC query for this without looking at the options, what is the answer that I want? I want Aadhaar ID, name and age of person. So I would denote an iterator over person P, over the table of person. So it corresponds to a row in the table person. So P is a row in person, and what I want is P dot Aadhaar ID, P dot name, P dot age. Okay, so this is the output I want. Then I put the vertical bar, which can be read as such that person of P, which means P is a person. Now, uh, now, what is the other condition that we want? We want that uh, person should be joined with this table, which is a subtable of works where company name is XYZ, right? Because you use a select symbol, a select condition based on company name being XYZ on the works table. So I have there exists W, where W is a row in works, and uh, and W dot company name is equal to XYZ. Okay, so this is what gives you the inner table. And to join the two tables, you have that the common attribute W dot Aadhaar ID should be P dot Aadhaar ID. That is the join condition. So therefore option D is correct. Is this understood?
Yes, sir.
Okay. So one thing that should always be kept in mind. Okay, okay, I'll repeat it again. So when you're writing a TRC query, there are three things. There are three things that you should keep in mind. The first thing is whenever you're referring to a tuple or a row in a table, such as with P or W, you need to always define what P and W are. So defining that P is a person and W is works. So you should have first thing which is compulsory is defining these tuples or defining these rows. The second thing is that you need to identify if there is a join condition between one or more tables. For example, over here you had a join between person and a sub table of works. So you will also have a join condition. And then you would also have a select condition such as company name equal to XYZ. So this is another thing you need to take care of. So what are the three things? It is defining what P and W are, first thing. Second thing, to check if there are join conditions. And third thing, to check for filtration or selection conditions, such as w dot company name equal to XYZ. Okay, now let me repeat this answer again and explain what there exists W means. So first of all, what is happening over here? I am looking at works and selecting a sub table of works. Okay, so I look at works and I have select company name equal to XYZ. Then I do a natural join with person and project Aadhaar ID, name and age of the person in the resultant table. Okay, so when you're writing a TRC query, I would write p.aadhaar ID, p.name and p.age. So this is the output that I want. But this output is not for every person. This output needs to satisfy certain conditions. So what are those conditions? The first is to define what P is. So we state that P is a person, which is denoted by person bracket P. Okay, so person bracket P says that P is a row in person. Okay, now is that the only condition? That is not. There are other conditions. What is the other condition? That we want that person to be present in works and should belong to the company XYZ. Right? So I need to look for a row in works with company name XYZ and with the same Aadhaar ID. Okay. So I would look for a W. So the inverted EW means there exists a W. So there exists a row in works table such that I can match a person P with that row, and that row has company name equal to XYZ. Is this clear? Okay, so a quick sanity check that needs to be done over here is that are all these things are all these tuples or rows defined? So we used P and W. So are P and W defined? Yes, P is defined by person P and W is defined by works W. So that is the first check that we need to do. The second check, have we mentioned a join condition? Yes, we have mentioned a join condition, that is w.aadhaar ID equal to p.aadhaar ID. And finally, have we mentioned a select condition? Yes, we have mentioned a select condition which states that w.company name equal to XYZ. So if you have if these three things are ensured, then you can be more confident that your answer would is correct.
Uh,
Okay.
s-
Yeah.
Also, in the previous question, is it necessary to mention like after such that W, then bracket works and small w?
Yeah,
So
yeah.
we need to mention every time that we are joining with another work table.
Yes, yes. So works of W is necessary because I could also have said that a row in person table would not be referred to using P but W because that's only a variable, right? So if you're familiar with Python programming or C programming, you know that variable names are not do not have any bearing. If I replace for I equal to 1 to 100 by for k equal to 1 to 100, that does not really change any logic. So therefore it is necessary for you to define that W is a row in works. Otherwise it could be either in works or in person or in company or anything. Okay. So does that clarify your answer, your question?
Yes.
Okay,
Thank you.
thank you. So moving to the next question. Uh, Consider the following relational database scheme where roll number and course ID are foreign keys in enrollment, referring to roll number in student and course ID in courses respectively. So you have student, which has roll number, which refers to enrollment roll number, and you have course ID, uh, where roll number and course ID are foreign key in enrollment. Okay. So in enrollment you have roll number that refers to student roll number, and in enrollment you have course ID that refers to course ID in courses. Now you are given a TRC query which is s dot roll number and s dot name such that s is a student, and for all e, it is not the case that e is an enrollment, or it is not the case that e dot roll number equal to s dot roll number. The question is, you need to identify the interpretation of the above query. So it might be difficult to see what does this correspond to in the raw form that you have over here. But if you try to take out the negation sign outside the for all e, I think it might become much easier to interpret. Okay, so is there anyone who has an answer for this? So is it the details of student who enrolled for at least one course, for exactly one course, for no course, or for all course? Okay, so the answer is that it corresponds to students who have, yeah, for no courses. And an easier way to look at this is to actually bring out the negation sign. So if I bring out the negation sign from here, so not enrollment E would become enrollment E, and not E dot roll number equal to S dot roll number would become E dot roll number equal to S dot roll number. And the OR sign would become an AND sign when we remove the not sign outside. And the for all E would become there exist E. So you would have not of there exist E such that E is an enrollment and E dot roll number equal to S dot roll number. So what does this say? That we want roll number and name of all students such that S is a student and there does not exist E, that is a row in enrollment, such that E dot roll number equal to S dot roll number. So this is essentially a retrieve name and roll numbers of students who have enrolled for 0 courses. So is this understood? Are there any doubts in this? Okay, so I think we can stop here. Okay, you want me to repeat it again? Fine. So did you understand why? Okay, let me just paste these together. Yeah. So can you see why the TRC query on top is the same as the TRC query at the bottom? Is that understood?
Repeat one more time, sir,
Okay.
please.
Okay. So do you know that not A or union not B? Let me just write that. So not A union not B is the same as not of A intersection B. Do you know that these two are the same? Okay. So in that case, I hope you can appreciate that not enrollment E or not enrollment or not E dot roll number equal to S dot roll number, you can take the not out and you would have enrollment E and E dot roll number equal to S dot roll number. Is that much fine? Only the not being taken out. Okay. Now there's also so if you have for all E of not of, let's say, X, which is the same as not of there exist E, okay, so the capital A which I have written should actually be inverted. So for all E of not X is the same as not of there exist E dot X. Okay, so when you take out the not outside the X all the way outside, the for all becomes there exist. So do you see why the for all the inverted A became the inverted E? Okay. So if you understand that the first and the second are equivalent, what does the second one say? S dot roll number comma S dot name, which says that you want to retrieve roll number and name of what? Of S. But what is S? S is a student. And the not of there exist E means there does not exist an E such that E is an enrollment and the roll numbers in E and S match. Okay. So S is a student such that there is no enrollment corresponding to roll number of S. So these are all students who have registered for no courses. Is this understood? Okay. So yeah, I think we can stop over here. And there are only a few questions remaining, but those would take slight amount of time because I think you would have to write your own TRC queries for those. So I think we'll continue this in the next tutorial. Okay. So thank you for joining. If there are any questions, you can feel free to stay back. Otherwise, you could drop out of the meeting, and I hope you have a great weekend. Thank you so much.